Hey guys, this is question MM148 of the Maths Methods Fortify study guide. Now we've got this application style question here in our Trig chapter. Let's go through it. So we've got, while Zoe and Jessica are riding a Ferris wheel, they realise that as the wheel spins, the height of their carriage above ground level, h meters, t minutes after the ride starts, can be modelled by the function h of t equals a take b cos of ct. Once the ride starts, it takes the girls 2 minutes to reach the top. So that's very, very important. And our question asks us, if the bottom of the wheel is 3 meters off the ground and the diameter of the wheel is 16 meters, find the values of A, B, and C. The wheel does not stop during a regular ride. Awesome. So we've got this Ferris wheel. Something like that, I guess. The bottom of the wheel is 3 meters off the ground. So this is 3 meters. The diameter of the wheel is 16 meters. So this bit here is 16 meters. And it takes them 2 minutes to get to the top. So from there to there is 2 minutes. Sweet. So, oh, that actually looks like a globe. That's cool. So, we're trying to find our values of A, B, and C where h of t equals A take B cos of ct. So let's just do this step by step. Let's go with the period first. Okay, so our period is equal to the time it takes to do one full cycle. Okay. So from here all the way to the top and all the way back is one cycle, which is one period, okay? If it takes them 2 minutes to get to the top, we know that the wheel doesn't stop during a regular ride because it tells us that. So 2 minutes to the top and 2 minutes around, just keeps going at the same speed, which means that the period is equal to 4 minutes, okay? If the period is equal to 4, remember our trig, well, our sine and cos period equation is 2 pi over b, which means that, and in this case, our b is actually c, our coefficient, which means that c is equal to 2 pi over 4, which equals pi over 2. So our value of c is pi over 2. There's our first mark. Awesome. So from here, we can work out a and b. So we know that the bottom is 3 meters above the ground. We know that the diameter is 16 meters. So if the diameter is 16 meters and it keeps going around and round like this, it's actually revolving around our midpoint, okay, which is our B value. So, sorry, our B value is our amplitude, sorry. Let's start with the amplitude. So, it's revolving around this point. From here to here is 8 meters because it's half of this 16, and from here to here is our 8 meters. So, from the midpoint to the max is 8, and from the midpoint to the minimum is 8. Which means that our amplitude is equal to 8, which means that B is equal to 8 as well, because B is our amplitude, which is our number at the front. If the bottom of the Ferris wheel is 3 meters off the ground and our amplitude is 8, that means that our midpoint here is 3 plus 8, which is 11, which means that our A value is 11. That's it. So, guys, just keep in mind that B is 8, not negative 8, because we're already taking away B, and B is going to be 8 as well. So there are 3 marks. Yeah, I think that's it for question A. If you have any questions about it, just let me know. But let's jump straight into part B, which will involve sketching our graph. So let's just rewrite this. Let's do it here. So our A value was 11 and our B value is 8. 11 take 8 pi over 2t. Cool. We can probably leave that there just for reference. And part B asks us to sketch the graph of h against t for the interval 0 to 8, a regular ride length on the axis below. Label all endpoints and axis intercepts. Awesome. So let's just start by doing this here. So t and h. Now, we know that our period is 4. Period equals 4 minutes. And the question asks us to sketch between 0 and 8, which means we're actually going to have two lots of cycles within this domain, right? So we know that it's a negative cos graph, so it's going to start at the bottom. Our midpoint is 8. Sorry, our midpoint is 11. Our amplitude is 8, which means that our minimum is 3. And our maximum is 19. Midpoint at 11. It is a negative cos graph, so it starts down here at the bottom. There's no horizontal translation, which is good. that allows us to kind of do this pretty easily. The period is 4 minutes, which means that it's going to come back to this same point at 4, which means that it's going to have a top at 2, top at 6, and back to the same point at 8, which means it's going to look something like this. And that's it. So we want to label our endpoints, which is 0, 3 and 8, 3. Now we don't have any axis intercepts apart from this 0, 3, so that makes it pretty easy. But we've indicated everything that we need to indicate on this graph. And this was part B, my bad, part B. We've indicated everything we need to indicate on this graph, so you don't really need to go any further with that. So let's move on to question C. So question C tells us, how many minutes have the girls been on the ride when they first reach a height of 8 meters? Give your answer correct to 2 decimal places. So this is just a 1-mark question, guys. This is a CAS-enabled question, so you can use your calculator to just sub this in, but let's just go through the algebra anyway. So how many minutes have they been on when they first reach a height of 8 meters? So we know that h is equal to our height, which means that we can just say that 8 is equal to 11 take 8 cos of pi t over 2. Which means that negative 3 equals negative 8 cos pi t on 2, which means that the inverse cos of 3 on 8, so we just divide both sides by negative 8, 3 on 8 is equal to pi t over 2. Awesome. Because we're looking for it in decimal form, and you will not be expected to do this by hand, it's not an exact value, so pi t over 2 is equal to 1.1864, which in turn means that t is equal to 0.76 minutes. And keeping in mind that we want it to 2 decimal places, it's only a 1-mark question, so we can simply write the answer, and that is it for B. So we know that that's the first time they reach a height of 8 meters because it's just our default value for t, and that'll always be the first value. So let's go to part D now. So, during a regular ride, for how long is Zoe and Jessica's carriage above a height of 14 meters? Give your answer correct to the nearest second. Cool. Well, we know that our graph looks something like this, like that, because a regular ride is 8 minutes, right? So we have 4 minutes here, 8 minutes there, and we're wanting to find the time that it's above 14 meters. So we need to find out first when it is actually equal to 14 meters. So we can say that this is about 14 meters, and we need to find out the time that it's above that point. So these bits here and these bits here. So the duration of time from here to here and from here to here. Cool. So let's find the first time that it's equal to 14. So by saying 14 equals 11 take 8 cos pi t over 2, we actually get to negative 3 on 8 equals cos of pi t on 2, which means that the inverse cos of negative 3 on 8 is equal to pi t on 2, giving us t equals 1.2477. Sorry, 2447. Cool. So this is our first mark, guys. So this here is t equals 1.2447. Our maximum occurs at 2, all right, which means that our distance from our maximum to this point is 2 minus 1.2447. So from here is equal to 2 minus 1.2447, which is equal to 0.755. Cool. So from here to here is 0.755, and they're above 14 meters for this, 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 and this, which means it's 4 times 0.755 is the total amount of time, which means that we get 0.755 times 4, which equals 3.02114 minutes. And we're actually looking for it correct to the nearest second. So what we're going to do from here is do 60 times 0.02114, which is equal to 1 second. So our final answer is, so this is, by the way, this is your second mark. Our final answer is actually going to be 3 minutes. So total is equal to 3 minutes and 1 second. And that's your third mark, guys. So please be mindful of how they want it. So they want it correct to the nearest second, so you need to convert the minutes into the second as well. Guys, that's part D. Please let me know if you have any questions about that. But let's jump into part E and go from there. So part E asks us, how fast are Zoe and Jessica traveling while on the wheel? Give your answer in meters per second. Cool. So we know that speed is equal to distance over time. All right, so speed equals distance over time. We know how long it takes them to go around the wheel. It takes them 4 minutes, right? We know that because it's told us that. What is the distance of this journey, around this wheel? That's what we need to figure out. So from here to here is 8 meters, right? To work out our distance is the same as the circumference of this wheel, or the circumference of a circle, which is equal to 2 pi r over the time. We know that the radius is 8 meters, so 2 pi times 8 over 4. This gives us a time of 4 pi meters per minute, because remember this 4 is in minutes, which means that we divide this by 60 to get the speed in meters per second, which gives us 4 pi over 60 meters per second, which gives us pi over 15 meters per second. And this is the speed. Awesome. So guys, your first mark comes by recognizing that you have to plug in these values, and then your second mark comes by actually saying what the speed is in meters per second. That's it for question MM148. Please hit me up if you have any questions. But apart from that, guys, have an awesome day.